Okay, so today we're talking about relations and functions. So at the top of the next page, if you'll write those two words, we have a few vocabulary words today, but I'm going to spread them out a little bit so that we're not just writing a bunch of stuff all at once, and we can do some cutting and pasting and drawing and things like that. So relations and functions. If you remember, our title of our first unit is called functions, so now we're kind of getting to where we're getting to what we really need to talk about. So the first vocabulary word is relation. A relation is any group of points. Any group of points. So anytime that I just say this group of points goes together, that's a relation. I don't even have to explain how they go together or anything else. It's just any group of points is a relation. A function is a special type of relation where each input has its own output. And I'll explain that in just a second. Go ahead and write it down. Where each input has its own output.
Could you repeat that again?
It's a special type of relation where each input has its own output. Okay, here's what makes a function special. If you kind of think about the Coke machine or the vending machines downstairs, I'm really upset because last year they switched from Coca-Cola to Dr. Pepper, so I don't visit the machine very often because I do not like Dr. Pepper very much. So I just bring my own Cokes up here. But when it was Coca-Cola, I was down there a lot. And our machine in our teacher's lounge, you put $1 in, you get a Coke out. That's how it works. Okay, what would happen though if some days I stick 50 cents in and get a Coke, and some days I have to stick $2 in and get a Coke, and I really don't know which one it's going to be? Do you think that's a functioning Coke machine?
Nope.
No. Now the days that it's only 50 cents, am I going to be happy? Yeah, because it's cheaper. But what about the person that owns the machine? They're not going to be so happy. The days that it's $2, I'm going to be kind of ticked off because I don't get my Coke. I have to pay $2. So if in a function, it's like it happens the same way every time. Like $1, 1 Coke, $2, 2 Cokes, $3, 3 Cokes, $4, 4 Cokes, so on. You see how that works? I don't put $1 in and get 4 Cokes, although that'd be kind of cool. Or I don't put $1, $2, or $5 and possibly only get 1 Coke every single time. Okay, that's not functioning. Okay, so that's a function. All right, so and we're going to do a lot with functions, so you'll kind of get this down as we go. But the first thing I want to talk to you about is just their graphs. So take this little sheet where you cut out the two graphs that are stuck together. Give yourself about, I don't know, 3 or 4 lines right there because we're going to write something, but glue those down kind of in the middle of the page. You can kind of tell which way it goes because it's underlined. That one is underlined. Just throw it away and we can get another one. Now, some of the glue, you guys, is left over from last year, so if it's old, just toss it and get you a new one. Don't put an old one back in the drawer because that serves no purpose. It's like putting an empty jug of milk back in the fridge. Does nothing but make your mom kind of angry.
Sometimes I do that.
Okay, so get that glued down. Leave yourself a little bit of space, or if you forgot, you can write under it instead of over it. So we're going to put how to tell if a relation is how to tell if a relation is a function. Because it's a special kind of function. Kind of like a square is a special kind of rectangle. Right? They're still rectangles, but it's a special kind. So this is a special kind of relation, the function is. There's two basic ways. The first way, none of the x numbers can repeat. So when you have a whole list of points, y'all know the first part of the point is the x and the second part of the point is the y, right? You remember studying that the last few years? Like when I name a point, it goes x comma y. So none of those x numbers can repeat. They all have to be different. If they repeat, it's not a function. It's a relation, but it's not a function because any set of points is a relation. So none of the x numbers can repeat. That's one way. The second way is called the vertical line test. The vertical line test. And this one's done on graphs. So if you want to put in the parentheses, you can put on the graph. That's what we're going to do with these two graphs. The vertical line test, it says, if I draw a vertical line, which a vertical line is straight up and down, it only touches that graph in one place at a time. So any vertical line. So if I draw a vertical line here, how many times does it touch that graph, that drawing? Once, right there. If I draw it over here, how many times does it touch? Just once, right? Anytime I draw a vertical line for this one, there's nowhere where I could draw a vertical line and it would hit that little picture twice. So this one is a function. Because the vertical line test passes. It only hits it one time every time. But the second one, if I draw a vertical line, right there it hits 3 times. 1, 2, 3. Over there it hits 3 times. Even out here, it's going to hit twice. If I'm really careful, I might be able to get one of them to touch one time right there on the edge. But because of all these other times that it touches more than once, that one's not a function. Okay? So this one's not a function.
The second one's not a function, right?
Correct. The second one is not a function. The first one is. Did y'all see the difference? One of them, you draw these straight lines, it only hits it one time. Yes?
So the ones that just hit one time is a function.
Is a function.
The one that hits more than one time is.
Correct. Correct. Okay, so that's just how you kind of tell whether a relation is a function. So we're going to do a little bit with a couple of relations. We're going to decide, are they functions? But we're also going to learn the 4 ways how to write them. So there are 4 ways to represent a relation. There are 4 ways to represent a relation. The first way, what have we been looking at? What are these?
Graph.
Graphs. The first way is a graph. The second way is a list of points. So you've got a graph, you've got a list of points. The third way is a table, which you'll hear me call this a T-chart a lot, just because it looks like the letter T, but a table. And the fourth way is the only one that's probably new to you guys. It's called a mapping. And I'm going to show you what that is in just a sec. So there's your 4 ways to represent a relation. A graph, a list of points, a table or T-chart, and a mapping. Okay, so we're going to do 2 examples of these, and we're going to use these graphs here in just a second with those. So the first example, example 1. Here's I'm going to do it from a list of points. So I've got -2, -1, -1, 0, 6, 3, and -2, 2. And then when it's a set, you put those little squigglies on the outside edges. That's what I call them. You don't have to draw them pretty, you can just make a squiggle line. Okay, so write down that list of points. That's one of the ways to represent that. Is this a relation? Yes.
What does the second one say?
-1, 0?
No, like the.
Oh, list of points. List of points is number 2. Table is number 3. And mapping is number 4. Okay, so this, you said yes. It is a relation because what is the definition of a relation? Any group of points. Is this a group of points? Yeah, so that's a relation. So it is a relation. Okay, so this is the graph. I mean, this isn't the graph. This is the list of points. We're going to take one of your little graphs and glue it down here so that we can graph them. So I've got my list. I'm going to do my graph. And remember, each one of those points is the X number first and the Y number second, and you always go back and start at the origin when you count them. So if I start at the beginning, the first point I have is -2, so I go -2 over, -1 down. There's my first point. -2, -1. To the left 2, down 1. I still got a couple people glued. I'm going to let y'all catch up. Let me zoom in a little bit. Maybe that'll help too. Okay, so -2, 1. The next one's -1, 0. So you're going to go over -1, but you don't go up and down at all. So that one's right there on the line, on the axis. The next one is 6, 3. So 1, 2, 3, 4, 5, 6. And then up 3, because it's positive. So that one's right there. And the last one is -2, +2. So there's my 4 points on this graph. So far I've got my list, I've got my graph. What's one of the other ways we need to do? Table or mapping, right? That's the last 2. So table, it looks like this. Here's a table. These are super easy. X and Y. And you just write the points. Just rewrite the points, but put them on the table. So -2, -1. -1, 0. 6, 3. And -2, 2. There's your table. Nothing fancy, nothing special. You're just transferring those points onto a table. Y'all have seen those before, I hope. Okay, the only weird one is called a mapping. And a mapping looks like 2 ovals. So it looks like this. You got an oval here, and you have an oval here. Okay, these are your X's, these are your Y's. Here's the deal. You're not allowed to write a number twice in a mapping. So in the X's or in the Y circle. So if there's X's that repeat, I can't write them twice. If there's Y's that repeat, I can't write them twice, just once. So in the x bubble, I have a -2, I have a -1, and I have a 6, but I'm not going to write that -2 again. It's the only one that's kind of weird. I don't know why they do that, but you just don't write it again. And in the y bubble, I've got -1, 0, 3, and 2, because nothing repeats there. And once you've got them written in there, you kind of draw little arrows like you're in 1st or 2nd grade and you're matching. So like the -2 goes with this -1 right there. The -1 goes with the 0 right there. Usually they're almost straight across from each other. 6 goes with 3. But then this last little 2 needs a -2. So from -2 down to that 2. There's your mapping. You have to draw your little arrows. So it's not hard, it just is different than what y'all have done before. Okay, now, before we move to the next one, looking at this one, we already said it's a relation because it's a group of points, but is it a function? No, why not?
Because the 2 points are like right.
They're lined up. If I did a vertical line right there, I would hit both those points, wouldn't I? It's not a function, which means 2 of the x numbers repeat themselves. That -2 is twice. So this one's not a function. Everybody understand how we figured that out? 2 of the x numbers, the -2 is listed twice. Or if you look at the graph and I draw a straight vertical line right there, I might hit 2 points. Depending on where I draw my line, there's one that's going to hit 2 points. Okay, let's do another example. This example, we're going to start with the table. Example, we're starting with the table. What's another way to write it? I have 4 ways. So I did the table already. What else do I need? A list of points. Okay, so let's do a list of points. So you do a little squiggly. So the first point is 3, 0. Then -2, 4, then 1, 1, and 0, 4. So there's my list. We know we're going to need a graph, right? Graph. So we can put all these points on the graph. Okay, so that first point is 3, 0. So you go over to the right 3, but you don't go up and down at all. So it's right there. The next point is -2, so to the left, -2, +4. So it's right there. 1, 1 is over 1, up 1. And 0, +4, you don't go left or right at all, but you go up to the 4 and put a dot. So there's my 4 dots. So that's 3 of the 4 representations. What's the last one? The mapping. So we got to draw our little ovals or bubbles. And what's the one rule about these? Don't repeat the numbers if they repeat. So in the X one you have 3, -2, 1, and 0. Nothing repeats in that one. But in the Y I have 0, 4, 1, and I'm not gonna write the 4 again. And then draw your little arrows. So match them up. 3 goes with 0. -2 goes with 4. 1 goes with 1, and 0 also goes with 4.
You said with 4? Wouldn't it be 0 goes with 0?
No, but you're matching them up based on their points right here. So the 3 goes to the 0.
Okay.
So you match them up to the points. I probably wasn't clear about that, how I decided that. What do y'all think about this one? Is this one, first of all, is it a relation?
Yes.
Yes, it's any group of points, so it's a relation. Is it a function?
No. Oh,
I hear both answers.
no, yeah, it is a function.
It is a function, why?
Because
Because
it
the
all-
x doesn't have the same number.
The x doesn't have the same number, what's the other way you can figure it out?
It is
The
lines.
lines.
The lines. So if I draw straight lines, is it gonna hit more than one point? No, so yes, this is a function. Good job. Okay, so now we're gonna look at the variables that are in functions, and we're gonna do two definitions, and then we're gonna draw a picture. And then we're gonna do the little word problems that are on that notes page. They're really not word problems, you're not having to do much math, but. Okay, so our first definition is the independent variable. The independent variable is the variable that determines the outcome. And in parentheses, put the x beside that because it's always the x numbers. The independent is always the x numbers. It's the one that determines the outcome. And you're going to talk about this a little bit in biology also. I don't know about IPC,
What's that?
but it's another science class. But the independent variable is the one that determines what happens. Okay, it depends on how many dollars I stick in the Coke machine on how many Cokes I'm going to get, right? So the independent variable in that is how much money I spend. If I keep putting money in, I'll keep getting more Coca-Colas. Well, not in this one because it's Dr. Pepper's, but you know what I mean. Like we'll put more money in, we'll get more out. So dependent variable this is the result or the outcome. So in that scenario, however many Coca-Colas I have, that's the result. That's the dependent. This is always your y numbers.
Have you ever had fried Coca-Cola?
Have I had it fried?
Yeah, like fried
No.
Coca-Cola.
Like at the fair? Oh, I didn't get to taste that. I would have loved to though. Okay, we're gonna draw a silly little picture because I'm kind of silly and weird. But a way to kind of help you remember which one's which. So I want you to draw a great big X down here, like this. And then a great big Y, but it needs to be the capital Y that looks like this, like from elementary school. Okay, great big X and a great big Y. And then we're gonna draw faces on them. So make a little face right here. The X face is really happy, so make it a really happy face. The Y face is not so happy. So make it not so happy. You can draw them? Draw my pictures, come on. Okay, then we're gonna put feet on them. There we go. And then a little dotted line like that going down. So these are our fun little pictures, and you'll hear me refer to these a lot during the year. Independent. Somebody tell me what the word independent means. If I say you're an independent person, you can do it on your own. You can take care of yourself. You guys are working toward independence, right? Some of you may be closer than others to being independent. some of your parents probably don't want you to be so independent, and they're trying to hold you back a little bit. But you're working to get there so that you can be an independent adult, take care of your own bills, take care of your own food, take care of whatever it is you need, take care of yourself. Dependent means you have to have somebody to help you out. Like you can't do it on your own. That's what dependent means. Independent X. So this is the independent. X is always independent.
Like independent variable?
Yes, X is always the independent variable, so he's independent because he can stand on his own 2 feet. He's got 2 feet, he can stand firmly on his own 2 feet. So he's independent. Does that kind of relate to y'all? Do you kind of get where the independence and standing on your own 2 feet makes sense? If you've heard that saying before, that means that you're independent. You can stand on your own 2 feet. That means you can take care of yourself. Okay, so then poor Mr. Y over here is dependent. Dependent, and this one needs help from X to stand. Because he only has one leg. Okay, so the Y, he can only stand on that one leg for so long by himself. He's going to need some help. He's not so thrilled because he's going to fall over if he doesn't get some help. Okay, it's kind of like if you try to balance something. It's a whole lot easier for you personally to balance on 2 feet, obviously, than it is to stand on 1 foot. That's why that whole yoga pose that looks like a tree or whatever, I don't know, you know what I'm talking about? Where they stand and they put the 1 foot up on their knee and they do this. Okay, that one's like really hard because you're on 1 foot, you're trying to balance all this stuff. But if you could have both feet on the ground, it'd be awesome. You could do it, right? So independent, stands on its own 2 feet. Dependent, needs some help because it only has 1 leg. All right, X always is independent. Y is always dependent every time. Okay, so we're going to look at some examples of these. So I want you to cut out each individual little word problem type thing that's on your paper and a little chart that says memory and cost, which is kind of outdated, but we're going to use it anyway. I don't know what order these are in. Looks like cooking time is the first one. Then Maria. You can kind of just spread them out on the page, leave a few lines in between each one so we can write. We don't have to write a whole lot. Get those cut out and glued down. The little T-chart, yes. The one that says cost and memory. Yes, but the extra graph, there's going to be 1 extra graph on there. That's just going to have to go in the recycle bin. I put too many on there, sorry. Okay, so you're just kind of gluing them down, spacing them out on the next page. This is our last page today. We're just going to practice picking out which one is independent, which one is dependent, is all we're going to do. No mathematical computation involved. You perfectionistic people are having a hard time with all this cutting, trying to get them all right. So I always have a few that want it to look really, really pretty. So they work really hard, but sometimes it takes them a lot longer.
What is this one?
That one goes at the very bottom. I just put it on the bottom of the same page.
Because I didn't see it, so that's how.
I zoomed in so that y'all could read it a little better.
Okay.
So you can't see my whole page up there.
Yes, I will, because I can't see it.
Okay, so this weekend when you have your homework, hopefully when we finish notes, I'll get you guys all signed up. And if you totally look at your homework and go, I don't remember how to do this, I even look at my journal and don't get it, you can go online and watch me do the lesson again. And it'll refresh your memory. Even if you don't watch the whole thing, if you just like fast forward it to the part you need, you can do that. There's an app that can go on your phone that you can watch it from your phone even. So it's kind of a cool deal.
What's the app?
It's Schoology. I'll show you in just a minute when we finish.
Does that just look like Drive or something like that?
Okay, at the very top of the page, I want you to write this. Blank depends on blank. Which means this first one's going to be dependent. This last one's going to be your independent. Blank depends on blank. So every time we look at a situation, we're trying to figure out which one's dependent and independent. Fill in the blanks to figure it out. Blank depends on blank. And I think you'll get the hang of it after the first couple of them. The cooking time for an unstuffed turkey is about 20 minutes per pound of turkey. What would be the independent and dependent variables for this situation? Okay, so blank depends on blank. First of all, what do you think your two variables are? What two things are related to each other? And there's a clue word that says per. That kind of helps you out. They're usually right around on each side of that. So what do you think the two variables are going to be? Anybody have an idea? I guess at one of them? What two things are changing? Minutes is one of them. Good. Circle minutes. So what's the other thing that kind of relates to minutes that changes also? Pounds. Okay, so that little word per in the middle is like a clue that, hey, the variables are right here by me. Okay? So minutes and pounds. Which one depends on the other one? Do the number of minutes depend on the pounds? Or do the pounds depend on the number of minutes?
Depends on the minutes.
Okay, if pounds depends on minutes, that means the pounds will change based on how long you cook it. So it needs to switch, right? Okay, this one's kind of a little bit harder. The time depends on how big the turkey is, right? Which means if the turkey's smaller, you cook it shorter. If the turkey's bigger, you cook it longer. If you switch it the other way, that means that if I cook it longer, it gets bigger. If I cook it shorter, it gets smaller. That doesn't work. So it's going to be the time or the minutes. Minutes depend on pounds. So the minutes are dependent. The pounds are independent. This is your Y. This is your X. So if you were going to set up a table or a chart and start like filling in the chart, the X's would all be pounds, the Y's would all be minutes. Okay, on the next one, you can mark out this part about working no more than 16 hours a week. That's just useless. We don't need that. The basic situation is she's babysitting. She gets $7 per hour. And if we're looking at how much money she makes. So remember, per is kind of a clue word. What do you think your two variables might be? Okay, it's not going to be the 7, but it's dollars. How much dollars she's going to have. How much money. So dollars and hours. So, does her money depend on how many hours she works?
Yes.
Or do her hours depend on how much money she makes?
No.
It's the other way around. Her money depends on,
Yeah.
this one makes more sense than the cooking thing because y'all can relate to this one better. Okay, so money depends on hours. So this one's dependent, Y. This one's independent, X. So it's usually, when you write it out like this, you have them kind of backwards. But that's okay. You know which one's which. The next one, when measuring the number of cones sold in correlation to the outside temperature. What would be the independent and dependent variables? Do the number of snow cones sold depend on the temperature, or does the temperature depend on how many snow cones we sell?
Temperature depends on the snow.
Man, I wish it was like that. If we sold more snow cones, it could get cooler, right? Like, temperature doesn't depend on how many snow cones I sell.
What snow cones?
If I sell more snow cones, does it change the temperature outside?
No.
If I sell less, does it change the temperature? It would be awesome if it did, because we could control the temperature. It's the other way around, right? The temperature causes the snow cone sales to move. So the snow cone sales depends on the temperature. So sales, and I forgot to, sales and temp are the two things. Sales depend on temperature. So this is dependent Y, this is independent X. Two more. And then y'all are going to do a partnering activity, but while you do that, I'm going to have you sign up for Schoology and Remind 101.
I already have one.
Oh, sorry. You just have to sign up for my class. You do Remind 101 already? Okay, so it's just you have to add my class to it. Okay, John notices that when he practices free throws for a few minutes after practice, his percentage made increases. He reasons that if he practiced longer, his percentage would increase more. That makes sense. What are the independent and dependent variables? So what do you think our variables are here? What two things are changing?
The percentage and
The percentage and the what?
the time.
The time he spends practicing, right? Those are the two things we're looking at. So, let's see, time practiced and free throws. So blank depends on blank. Does the time practice depend on how many free throws he makes? Or does the number of free throws he makes depend on how much time he practices?
The number of free throws.
Okay, so free throws made, and I think these exact questions are on your homework. Depends on time practiced. So this is dependent, not X, Y. This is independent, X. Okay, the last one is a little outdated. It's a T-chart or a table of memory of a flash drive and how much it costs. And these are in megabytes, which y'all's flash drives now are not even measured like this. But, so if it's a 32 megabyte, it costs $19. 64 megabyte, $29. 128, $39, 256, $49. The cool thing about a T-chart, you already know which one's X and which one's Y. Because they will always put the X on this one and the Y on this one. So you don't even have to guess on this one because which one is always independent? X, because it stands on its own 2 feet. So memory is independent and cost is dependent. You already know that. You don't even have to hardly look at it. Okay, any questions on how to figure these out? You pretty much got it? Okay, let me turn this off real quick and then we'll, maybe.